Good morning down under and good evening here in Raleigh, North Carolina, where I am today. Many of you have heard me before, and you should know that I'm a hedgehog, as Jim Collins describes it in his book, Good to Great. There you can see what that is. Basically, he talks about hedgehogs being the most successful managers, and the companies have been very successful because they have stuck to their beliefs and their philosophy and their products for long term and done it just better and better and better and better. And that is what I am about. And I do not change my message unless it's proven to be wrong. I'm not that stubborn. No, I can change, but more than anything else, I know that it's working because I have seen it work. I have worked with people who has implemented it and got fantastic good results. So don't just say, okay, I heard it before, whether it is from me or from someone else. Just ask yourself, what have you done to improve? My background is industry. I spent about 8 or 9 years in the merchant marines, in the engine rooms, from apprentice up to chief engineer, and I have a Bachelor of Engineering in Marine and Mechanical Engineering. IDCON Inc. was established in Sweden in 1972 as Idhammar Consult AB, and in 1985 I started here in the United States, and I named the company IDCON Inc. And we have today 50 consultants and associates with alliances in Eastern Europe, Latin America, Quebec, Russia, Scandinavia, and Southern Europe. What do we do? And I mention this because it's important to you people who are maintenance managers. Do you have a mission? And what does that mission tell you to do? Do you say that you are a service organization to operations? Or do you say, no, in a partnership with operations, our mission is to deliver overall reliability or equipment reliability. And if you do that, you have to believe that your costs will go down. So to cut the maintenance cost, just cut it. It's a no-brainer, and it won't really work because the only thing you do is actually that you postpone maintenance, and it will most probably cost you much more later. We have many examples in our infrastructure where bridges has fallen down, how pipeline has started leaking and so forth, and in most cases this has been deferred maintenance, as they call it. I'd like to talk a little about knocking bolts and the story behind it, because it has a good message, I think. It's about know-why training. We don't only talk about teaching people how to do things. It's very important to tell them why. I was a young sailor on my first ship, which was a 40,000 tons tanker, which was a big ship at that time, 1961. So I've been in this business for over 60 years now. And that was actually the biggest ship that could go through the Suez Canal. Anyway, each trip up there to the Carg Island took 3 weeks out and homebound 3 weeks. And you only had about 18 hours to do some maintenance when you were in Carg Island. There was not much to go ashore anyway. But anyway, that was my life. You worked 4 hours, off 8 hours, 4 hours, 8 hours, 56 hours a week. Horrible schedule, really. But anyway, on the second trip, we went into a shipyard in Palermo in Sicily. And I thought, well, I'm going to go ashore and see the city and do what the older people on board the ship talked about. And I'm not going to go into detail there. But anyway, they said, no, Chris, you go down into the engine room and you take a hammer with you and a special ladder you can put up to the crosshead inside the machine. And these machines are giant diesel engines. They're about 30 feet or 10 meters tall. And the cylinder diameter is close to 1 meter or 3 feet. And the stroke is like something like 6 feet or 1.8 meters. So you climb inside them. And they said to me, okay, take the hammer and give every bolt you see a knock with the hammer. Just give them a blow with the hammer. And I'll tell you something. I was only 17 You don't ask, why am I doing this? You don't want to look like I don't know it. And I'm not sure that everybody else knew it either. But anyway, I did that, and I didn't know why. Had no idea why am I doing this. So I skipped a lot of them just to get rid of it, because I had then 16 crankcases to do this on, because there were 8 cylinders on each of these giant machines. So I skipped it, and I did it in record time. Well, anyway, later in my life, perhaps it was only 4 months later, in another ship, in another port somewhere in the world, same job, Krista, go down and you do the knocking bolts in the crankcases. Then I learned why I did it. Because it's quiet in the engine room when you are in the port. So you ring the bolts. I give a knock and a bolt, and then I found a bolt that sounded different than all the others. Then I understood what I was doing. I was checking for loose bolts. And that's a very, very important preventive maintenance procedure. Because if any of these bolts or nuts get loose in a crankcase, it can cause sparks, and that can cause a crankcase explosion. And that has happened in board many ships. Many people have died from those, and very serious damages to engines and to the ship and so forth. So it was a very important thing to do. And after that, I always did it in the right way. And that led me to also to call my latest book, Knocking Bolts. And that is a book about basic inspection techniques, predictive maintenance, work management, inventory control, case history stories from successful and not successful implementations. And it also talks about how to become a successful consultant and a consulting company. And I also have 2 other books, Results-Oriented Reliability and Maintenance Management, and it's also translated to Russian. Our partner in Russia has done a great job translating those. Okay, let's talk about the Roman aqueducts, AD 97. You can find this on Google, that what I'm saying here is really true. And here is a picture of the aqueducts. I don't need to go through the details of it, but they had a very, very precise slope. So the water was running at a steady pace. It even went underground and then pushed up the water like a pipe down to the next level. And it was an incredible thing. Some of them are still working today. But anyway, around the year 897, the emperor in Rome found that there was a shortage of water in Rome. And that is a very, very serious problem. He realized that that is a problem that I have to fix in some way. Because if you don't have enough of water for all the people, for cooking, drinking, all their baths they had, and of course, even the sewage system, there could be really a revolution. So he actually assigned, and I need to read this, Sextius Julius Frontinus to take care of this. And one option was, of course, what I looked into was we have to build 1 more aqueduct. That is obviously one option. And that would take a very long time and, of course, cost a fortune really to do. Instead, what he did was that he started looking at, so what is the maintenance? How does the maintenance look at these aqueducts? How well are they performing? And he then decided to go out and do the following things. Do site visits and then document all the aqueducts. So he knew where they were, what segments they were, numbered those sections, so you could find out easily where you need to do a repair, for example. It's the same thing as you do in a plant. You need to have a map of all the equipment you have. And that equipment has to have numbers, so you know to work on the right piece of equipment. He also did inspections, of course, to find out what was the status of these aqueducts. And then he instituted daily meetings. So when they did inspections and found a problem, they then had a daily meeting to say, what are we gonna do and when? and he did work preparation. This is work management. This is planning and scheduling. Nothing new since about 2,000 years. And we're going to do preventive maintenance. And the preventive maintenance was to find better methods to so we can avoid any problems. It was mostly based on the material they used and so forth. And it is really interesting that once these aqueducts were built, they had to be maintained and protected, of course. And the city of Rome at one time employed about 700 maintenance people just for that purpose. And the excellent planning of the ancient Romans ensured that maintenance requirements were incorporated into design. How many of you actually do that? How many of you actually design equipment based on maintainability and reliability design? Well, they did it 2,000 years ago. And for instance, underground sections of aqueducts were made accessible by means of access holes and shafts. When major repairs were needed, engineers could temporarily divert water away from a damaged section. What do you call this? The basics of maintenance that we still do in the same way today. I talk about the process, not the technology. That's another story. But anyway, they thought of reliability and maintainability design in a very early stage. And so not much is really new when it comes to work processes. So what is new then? Well, think of it a little. What is actually new? Well, I'll tell you something. We keep changing names on reliability and maintenance management, but the principles of how to manage RMM has not changed much. I remember very well when I worked and I started working in a big plant, and we had to keep track on the equipment records, what we today would call the bill of material, on Cardex cards. And you had to manually write in what you did, what parts were used, and what parts belonged to that. But there was no integration with the store, for example, because that would require a computer. But still, the principles were the same. And what has changed and continues to change dramatically is really technology. There you have a lot of changes, of course. And you know, I'm a lucky man because I live very close to a store that, I don't know if you have it down under, it's Home Depot. You know, that's my therapy place. I can go in there and look at the latest tools, spend hours if I could. And you know, when I was starting this consultancy in 1972 around, I used sometimes infrared cameras. And those cameras were big. You had to have a cart to pull the equipment on, and a handheld camera. And you had to have liquid nitrogen to cool some elements to make it work. Well, I can tell you something. I was at Home Depot about 5 years ago, and then I found this little thing. Can you see that? That I hook this little thing up to this my phone, and there I have an infrared camera. And of course, it might not be as good as the more expensive types that can be more precise, but I have used it to inspect couplings, for example, to find a coupling is hot. That means that it's misaligned, most probably. I have used it to find the studs behind the walls when there have been difference in temperature in my house and outside, and I can find where I can hang a picture and so forth. So that is, and I can give you many more examples, but this is an improvement the whole time, and I come back to it a little more. And I will come back to this also in the masterclass and talk a little more in detail about these things. So one thing that really caught my attention, that was what Bill Gates said, and I think it fits very well here, that the first rule of technology used in a business is that automation, new technology that is, applied to an efficient operation will magnify efficiency because you're ready for it. You have your systems, your processes, your people trained. You're not in what I call the circle of despair, which is reactive maintenance. Because if you have too much of reactive maintenance, you're not going to get the benefits of new technology. Because the second is that automation, new technology, applied to an inefficient operation will magnify the inefficiency. So if you are in a reactive mode, that means that, okay, about, let's say, 70% of maintenance is not truly planned and scheduled in detail the day before you are to execute. And for a shutdown, you most want to talk about 3 weeks before or something like that. Then you are in a circle of despair. And you know something? The most common reason why you have a lot of priority 1 jobs is not that they are priority 1 jobs. It's because it's an emotional priority number 1. It might all come from operations who has to put the priority 1 on a work request, because if you put priority number 3 and do it when you can, you will never get it done. So you over prioritize. And many times that leads to that you as an organization will say, yes, sir, I will do that, because you look at operations as your king. I don't look at it that way. I look at operations as a very, very important partner. So you have to see to that you get rid of emotional priorities. Then the other one is, of course, equipment is failing and so forth. That can also be a case. But you need to get out of that circle of despair, as I call it, and I will talk much more about it in the masterclass. You know, Deming said a very wise words, and one of the most important things he said to me was that people cannot be more efficient than the system they work in allows them to be. Think of that. Here you have your front line. And who are the front line? That's your planners. That is your frontline leaders. That's your mechanics, electricians, control technicians, and also operator, of course. These are the people who are actually going to execute everything you plan and schedule and want them to do. They are the executors. They are the people you have to spend most time with. So it's very important that you then plan work and schedule work before they go to execute work. And that means that you set the system right so they can do, number 1, a safer job and a more efficient job, because they have the tools, they have the parts, they have the material, they have the time that you can use and to do the job, and therefore it is safer to do it, and of course much more efficient. So let's repeat a little of this and talk about the chain that must not be broken. You know, really what we talk about is the basics of maintenance, and that is number 1, you have to prevent. You have to prevent failures from occurring. And that means that you lubricate right. Lubrication is still one of the most important things you can do. One of the most important things you can do. It's not just to push in grease somewhere or to put oil somewhere. It is to see to that you store it right, that you keep it really, really clean and so forth. And it's also about precision maintenance. Alignment down with precision, down to 1/1000th of an inch. You figure out what that is in millimeters, by the way. And it should be when the equipment is in operating temperature, etc., 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 etc. It also includes things like operating practices. I met so many operators coming to me and asking questions such as, why can't we heat up the steam system faster? When we have a cold startup, it takes forever to get that machine going, because we can only open the valve a little and a little and a little, and it takes forever. Yeah, I know it takes forever. When I was on a tanker and it was in winter and we had steam on deck, for example, it could take more than a day to heat up. And why? So they asked me why. So people had just told them, do this, but not why. And you explain that, remember, here is steam coming into a cold pipe. What will happen to steam then? It will condensate. And if you open too fast, then that condensate will form a plug in that solid plug, actually, in that pipe. and it will rush through the system at about 120, 150 kilometers per hour. And when that hits an elbow in a pipe system or a control valve or any diversion of the direction, well, it can actually crack the pipe open. It's very strong force in that case, combined with thermal expansion and many other things. And that's why you have to open it slowly. And that's why you also have steam traps. And steam traps are not steam traps. They actually divert condensate. So they are condensate traps. And you have to see to that, yes, it's condensate coming out. And when there's steam coming out, clean steam coming out, or they actually close depending on the design, well, then you know we are doing this right. That was example of no why training, by the way. Okay, I could give many, many more examples on this. But anyway, what we here talk about, prevent and to do inspections. And with inspections, I mean everything from look, listen, feel, smell, which is a very, very big area of good inspections. You can't measure everything, actually. You still need people to listen, to look, to smell, and so forth. That is what we call preventive maintenance. And then to correct the failure, to plan the correction, to schedule the correction, to execute the correction, that's corrective maintenance, to make that make sense. And planning means that you decide what are we going to do, how are we going to do it. And you might also make an estimate on time right there. But you have all the parts, all the tools, all the lockout, tagouts, everything taken care of, and so forth and so forth. And to schedule, as you guys say, well, it is to say, when are we going to do this and how are we going to do it? In that order. And you see too that you always schedule to the work that has to be done, not just to the people you have available. No, you schedule to the work that has to be done. And based on that, you find the people, whether you need more or you need less. That's another story. And these are the very, very basics of maintenance, of course. Okay, if you look at this important chain, from inspect to plan, to schedule, to execute, that is the chain that must not be broken. Because you can have all this new technology, and you can measure things, and you can do condition monitoring, and you have the latest vibration analyzer, you have all these things. But if nobody acts upon that, and plan the correction of the problem, schedule the correction of the problem, and then see to that you execute the correction. Well, you have just wasted your time. We have to remember that when we do inspections with the infrared or with vibration analysis or wear particle analysis or online sensors, whatever they can measure, they don't prevent anything. It doesn't prevent anything. It only gives someone an opportunity to plan the job and then to schedule the job. They give them some lead time, and you will avoid reactive maintenance by doing this. This is, of course, nothing new. Well, go back to the Roman aqueducts, and it's exactly the same thing. And you know, you have so much new technology I'm talking about here again. And actually, most of it is in the inspect area. And I will come back to that a little later here. Just one more slide. When you now do all these things right, you inspect, you've done the prevent, of course. That is the very, very important part. You inspect, you find failures, hopefully, before they develop to a breakdown. Simple as that. And then you have a window where you can plan, schedule, execute. Then you also get time to improve. You will start doing root cause problem elimination. Not only root cause analysis, because that means that you just do an analysis. You need to see to eliminate the problem. And I call it a problem because you're a partner with operations. And because if you say failure analysis, well, it suggests that it's maintenance and mechanical and so forth, right? But anyway, much of that new technology is really within the inspect, and I'll come back to that. Now, if you look at this definition that we have here, because some of you might have a definition that says that prevent, inspect, and then correct all problems found during inspection. That is preventive maintenance. So that means that everything that is not a breakdown is preventive maintenance. Well, in that case, you might only have something like 70% would be preventive maintenance. In this model here, 10 to 15% is prevent and inspect of all the hours. About 60 to 70% is plan, schedule, execute. That is the corrective maintenance. And then the best performers I worked with has actually had 20% of all their effort hours to improve, to do root cause problem elimination and implement those problems they have solved. So it's not just sitting in a conference room and say, here's a chart, that's a problem. No, you go in and actually eliminate that problem. So let's just finish this by saying that much of new reliability and maintenance technology, and that is sensors, predictive maintenance technology, a lot of data collection and so forth, is actually in that box of inspect, as we call it here. And if you're not ready to take care of all the information you can get from that, the only thing you will do is that you will increase the backlog, because you can't get it through the chain, plan, schedule, execute. So that chain is what the Romans did, and I have been preaching it so much over the years, but I also implemented it and seen it work with some quite dramatic results, really, really good results. With that, I'd like to thank you all for doing this. And before I do that, I also like to mention that IDCON Inc., you can go in on our website, and I was allowed to mention that we have a lot of online training programs, and I don't need to read all of these because you can look at the slides later or go to our website, idcon.com. And again, with that, I'd like to thank Eventful Management for having me here again, and also for all of you listening. And I am just missing that I can't see you guys and talk to all of you men and women out there. So thank you again. And with that, I am very enthusiastic to take some questions. And remember also, prepare some questions for me if you will attend the masterclass, because then you can also prepare some questions. Thank you very much.